All right, so here are the notes for Unit 5.2. Three objectives. I'm actually not going to go over this first one in the notes because that's what we did mostly in class. The other two periods got to round right here. So these ones are actually just going to be these two inside of these notes that I'm about to do right now. So be able to evaluate a function using synthetic substitution. This is just another way to substitute to get basically inputs and outputs, and be able to determine the end behavior of a higher degree polynomial. Okay, so I'm gonna skip through some of this stuff. So these first parts were just us figuring out what a polynomial actually was. So once we figured out what a polynomial was, I think one of our classes got to the here. So I'm going to show you guys the two different ways to do this. So you have an input of 2. You're going to plug it into your function, which is a polynomial function to the 4th power, so it's a quartic. Direct substitution is the one that you already know. That's the one where you take the 2, you put it inside of each of the x's, and then you evaluate. So let's go ahead and do that one. So this will be f of 2 equals 2 times 2 to the 4th minus 8 times 2 squared plus 5 times 2 minus a 7. So now what this says is your function, when you plug in a 2, is 2 to the 4th, so that's 2 times 2 times 2 times 2, it's 16. 16 times another 2 is a 32. So this first one is a 32. Next one is 2 times 2, which is a 4, times an 8, 8, 16, 24, 32, so minus a 32. Then you have a 5 times a 2, which is a 10, minus a 7. 32 minus 32, that is gone because that's a 0. 10 minus 7 is a 3. So your function, when you plug in a 2, is a 3. All right. Input was 2, output was a 3. Synthetic substitution is just a different way of doing this stuff over here. So let me go and show you the setup. So I'm going to do it out, see if you can figure out how I did this. So that's a 2, 2, 0, negative 8, 5, and negative 7. Okay, 2, 4, 4, 8, 0, 0, 5, 10, and 3. Okay, so the end number is actually what you get out. So this one is 3. So if you look at this one we got a 3 when we plug into 2. This one we got a 3 also. Now I know I didn't explain this because I did this with my class too also. I showed the algorithm first and saw if people could understand how this came about. But I did want you to show you guys that they both got the same answer of 3 and another 3. Slightly different ways of doing it. A lot of people, after they see this way, they like substituting this way, but you don't have to. You can go back to this way. The reason why I'm showing this way is because eventually we're going to do a thing called synthetic division. And in order to do that, you have to know how to do synthetic substitution. So this is just an introduction to it. We are going to use it again later. So how did I do that? Synthetic substitution. First off, make sure you write it in standard form. You need to put placeholders for your missing terms. So next up, you're going to set up the bar with the coefficients, then bring down the first term, multiply, and combine. Okay, so to kind of show the setup, what I did here. So if you notice, these are all the coefficients: 2, negative 8, 5, and negative 7. 2, negative 8, 5, and negative 7. So the question should come up, where did this 0 come from? Well, that came from because we had x to the 4th. The next thing should have been an x cubed. It's not there, so technically you have plus a 0x cubed here. And then it went down to x squared, and then x to the 1st power, and then no x's at all, which was your constant part. So all your coefficients are actually 2, 0 for the x to the cube part, which is where this came from, so it's a placeholder. Negative 8, 5, and negative 7. So if you are missing one term, you have to put a 0 in. If you're missing more than one, then there should be more than one 0 holding its place. Okay, the next thing we did was, so I wrote what I was plugging in on the outside of this little bar thing. This is just to help us kind of organize our thoughts. It's kind of like an upside down division bar. Put the 2 on the outside and then your coefficients on the inside. Then the first step was to bring down 2. Now you just multiply and combine. So multiply by this number right here, whatever you're plugging in, that's what you're multiplying by. So 2 times 2 is a 4. Combine 0 and a 4, you can get a 4. Now you're going to multiply again. So 2 times 4 is an 8. Combine, and then you get a 0. Multiply, 2 times 0 is a 0. Combine, you get a 5. Multiply again, 2 times 5 is a 10. Combine again, and you get a 3. Same thing as we do here, okay? I'll show you guys on Monday how this came about, like why synthetic substitution works. It has to do with a method called nesting. But yeah, I'll show you that later. So let's go ahead and try that with this one. So this one, write in standard form. So right now it's in standard form. It's decreasing order. We are missing actually a couple of things. We got a 5, a 4. We're missing the 3 and the 2. We have x to the first and x right here. So we have 2 placeholders to put in, 0x cubed and a 0x squared. This is to the first power, and you can think of this like x to the 0 power if you want to think of the powers going down by 1. So 5, 4, 3, 2, 1, 0. Those are all your coefficients you should write. Okay, so now we're going to do a setup, upside down bar. Negative 2 goes out here. That's what you're plugging in. Now we're going to put in our coefficients. So the coefficients are 3, negative 1, 0, another 0, a negative 5, and a 10. All right. So now what we're going to do is, first thing, you bring down the first number. So you just bring it down. Okay. Then you just multiply and combine. So bring down the 3. Now you're going to multiply. Negative 2 times the 3 is a negative 6. Then you combine, you get a negative 7. Now you multiply again. Negative 2 times negative 7 is a positive 14. Combine 0 with a 14 and you get a 14. Negative 2 times 14 is negative 28. Combine, you get a negative 28. Negative 28 times 2 is a positive 56. Minus, combine with a negative 5 is a 51. 51 times negative 2 is a negative 102. Right? 1, 2, yep, negative 102. And combine that and you get a 92 negative. All right. All right. So yeah, when you plug in a negative 2, you get out a negative 92. So you can write your answer like this. F of negative 2 is negative 92. So remember, this is your input, so that's your x and that's your y. You could actually eventually plot that point. Like I said, we're eventually going to get into that, but right now it was just plugging in. Okay. So evaluate the following by direct substitution, then evaluate using synthetic substitutions. Basically, this one I wanted you guys to do it 2 ways, just so you can show yourselves that it works both ways. But since these are online notes, I'm just going to do one of them. So I already did that one. Now with this one, just a little warning here. This is not in standard form. You're going to have to move this to the front. This will be your second term, and then this will be your last term. And you do have a couple of placeholders. You're missing a constant, so you're going to have to put plus a 0 onto the end for this thing to work out. Okay. So I'll set up just the f of x equals 7x to the 4th plus, you don't have an x cubed, so 0x cubed. You have an x squared. You have an x to the first, and then you don't have any constant part. Okay? That's how you set that up. So your coefficients are 7, 0, 15, negative 2, 0. And then you would just do it both ways. First by, well, the first way you plug in a negative 1 here, here, and here, and then just do it directly. The next way, synthetic substitution, you have to write it like this. So sometimes it's more efficient, sometimes it's not. That's what the point of this one was. All right, end behavior. So we are eventually going to be graphing these things. It's a very, it's not really that bad of a process, but we want to do it in pieces. So the graphs can look like a lot of different things. Right now, we're just worried about the end part. So if the degree of the polynomial is even, so if you got an x squared, x to the fourth, x to the sixth, all those kind of things, basically both sides are going to go in the same direction. So the left side will be going up and the right side will be going up also. Now, there will be other stuff that happens in the middle here. We're not really worried about that stuff yet. All I want to teach you guys about is figuring out how the very end parts go. So either if it's an even polynomial, meaning the degree is even, both sides go up, or you might also have both sides going down. Okay. Once again, there might be all kinds of other stuff happening inside of here. I don't know. I don't really care at this point. All I care about is the up and the down, the end behavior of the actual graph. Okay. If the degree of the polynomial is odd, you're not going to have both of the ends go in the same directions. You're going to have them go in opposite directions. Okay. One side will be going down. The other side will be going up. And just like I just said, I don't know what's happening in the middle. I don't really care. All I care about right now is the end behaviors. Now, on the other hand, you also might have a situation where the left side's going up and the right side's going down. And like I said before, all kinds of stuff could happen here. I don't know. All right. The way you figure out if it's going, we'll call this the standard way, or if it's the reflection of it, meaning flipped upside down, is if the leading coefficient is positive. Leading coefficient. If your leading coefficient is positive, then they're both going to go up. If your leading coefficient is negative, then they're both go down. So even power, positive, up both sides. Even power, negative, down both sides. If the degree of the polynomial is odd, look at the leading coefficient again. If the leading coefficient is positive, then the left side goes down, right side goes up. So left side down, right side up. If the leading coefficient here is negative, then the left side will go up and right side will go down. All right. Now just a little proof concept here. So think back to y equals x squared. Now, if you notice, that is a even power. And we already know it's a parabola, but remember, I don't care about the middle part. What I care about is the end behaviors. So if you notice, they both go up. Leading coefficient's a positive 1 there. Now, if y equals to negative 1x squared, then we know it flips upside down, and both sides go down. Now, turns out the same thing happens when you have 2s, 4s, 6s, 8s, anything that's even. Okay? Next up is notation. All right, sorry, I had to pause it. Someone came in. So notation, f of x goes to something as x goes to something. So this is where a lot of people get confused. So f of x, when you think about f of x, when we first learned about it, we said it's the same thing as a y. So when I mention f of x, you should be thinking up and down. So let me grab my marker. Now, f of x is either going to go up or it's going to go down. X is going to go to the right or it's going to go to the left. So if the left-hand side of your graph is going up, so up to the left and up to the right. So if it's going up to the left, it looks like this. The left-hand side is going up. Up to the right means it's going up like that. So the way you would write this is, so first you're going to identify this piece right here. That piece right there needs to say f of x goes to something as x goes to something else. Now, since we're talking about the left side, that's what the x describes. It describes the left side. Now, if you're describing the left side, x is going to negative infinity. All right. Now, if you're describing the right side, that will be x going to positive infinity. Now, the reason why that comes up is because if you think about an x-axis, the left side of an x-axis is going to negative infinity. The right side of an x-axis is going to positive infinity because it's going towards positive numbers. So since I'm talking about the left side of the graph, That's x is going to negative infinity. Now the next question is it going up or down? Now this is going up. So the up and down part, so this is negative infinity for the x, positive infinity for the y. Let's say infinity sign. Now up and down, going down is negative infinity, going up is positive infinity. All right, so you need to ask yourselves, okay, on the left-hand side, what's happening? The left-hand side is negative infinity. What's happening? It's going up, so that's the f of x part. We know it's going up, so that's positive infinity. So that describes the left-hand side. Now we still got to describe the right-hand side. The right-hand side is this one. So same thing, f of x, whoops, it's not an x, there you go. F of x goes to something as x goes to something else. Now, once again, we're talking about the x. You can think of the x's first or the y's. I like to think about the x's first. Now I know I'm talking about the left-hand side. I'm sorry, the right-hand side. So the right-hand side means, if you remember the number line, the right side for x's is positive infinity. So as x goes to positive infinity, where's my graph going? So as my x's are approaching going to the right, my graph is going up. So to say my graph is going up, I would say f of x is going to, and then remember this is my y-axis, so it's going to positive infinity also. This is how you can describe end behaviors. You could also describe end behaviors just using arrows like this on the very ends. I want you guys to know how to do both. So an arrow representation, an arrow representation and function representation of it, okay? Now down to the left and up to the right. So if something's going down to the left, so on the left-hand side is going down, up to the right, so right-hand side is going up. So that's the arrow representation. Now let's do the f of x part. So f of x goes to something as x goes to something else. So the x part, talk about the left-hand side first. So the left-hand side will be negative infinity. So that's the left part of my graph. So the end behavior on the left is going down. So this is my left side. It's going down. So f of x tells me up or down. Down means negative infinity. So another way to read this is as you'll go down as you go to the left. So this is down and to the left. Now as you go into the right, or as you're going up, you're going to the right. Okay, so the other one, f of x goes to as x goes to something else. This one's the right-hand side. Right-hand side is positive infinity because you're going to the right on your x-axis. F of x is like your y-axis, or you're going up or down on the right. You're going up, so your f of x is positive infinity. It's always going to be in infinity signs because it keeps going on forever. That's why it's called the end parts, because the end parts don't come back down. It's just wherever it starts going, it keeps going that way. We're going to figure out the middle parts a little bit later on. So arrow notation, and I think this is called function notation. All right, so let's try this one. Now this one right now, it's not in standard form, so if you guys get a function and you got to describe the end behavior, go ahead and write it in standard form first. So standard form would be f of x equals 2x to the fourth minus 5x to the third plus 7x squared. Now the nice thing about standard form, once you get in standard form and knowing the end behaviors, you just have to focus on the first term. You don't care about the rest of the stuff because that stuff affects the middle. The ending parts is affected by here. So two things you got to check. First off, it's an even power. Once you know it's even, you know that both ends are going in the same direction. If it was an odd power, if this was your leading, if this was your degree, then they'd be going in opposite. So one side would go up, one side would go down. So even means that both sides are going to either go up or both sides are going to go down. What you want to look at is this front number right here, that 2. Okay, the 2 is a positive, so they're both going to go up. If the 2 was a negative, they'd both go down. All right, so once again, form the even power means they go in the same direction. Positive leading coefficient means they both go up. Negative leading coefficient would mean that they both go down because they both have to go in the same direction. Okay. If you have an odd power, that means one side goes down, one side goes up. The negative would mean that the left side would go up, right side would go down. So with this one, to describe it, first off, draw a little sketch so we know they're both going up. f of x, so describing the left side first, f of x goes to something as x goes to something else. So it's going up to the left. So to the left, and it's going up. Okay, f of x. Now we're going to describe the right-hand side. So we're describing this one right now. So on the right-hand side, which is positive infinity, it's going up again, so positive infinity. Okay, and that's basically how you do these. So yeah, tomorrow or on Monday, you will have a worksheet to kind of help you guys out with this. Go ahead and try that worksheet out. Actually, I'll do this one too, just because this one's a good example of the other one. So standard form, negative 3x to the 5th plus 10x to the 4th minus 6x squared. Focusing in on this one. The 5 means they will go in opposite directions. Now, normally, the left side goes down, the right side will go up, okay? If they're in opposite directions. Left side down, right side up. Now, this has a negative in the front, so that switches things. So instead of the left side going down and the right side going up, it's going to be the left side goes up and the right side goes down. So an arrow representation of this is this. Okay? If this was a positive, basically what would have happened would be, oh, hold on. So if that was a positive, basically all that would have happened, whoa. Yeah, that's not going to look nice and neat. Would be that this side would go down, that side would go up. All right. On a Monday, if you guys are having trouble memorizing that, I do have some ways that I can show you that's a little bit more intuitive why that works out. All right, so I'm gonna kind of speed this up. Left side, so that's going up. F of x up, positive, as x goes to, and then to the left was negative infinity. So as you can see here, you don't have to do it in the order I was showing you. Other side now, that's going down, so it's negative. And then that was the right side, so positive. All right. And that's it. Okay, so that's what your worksheet's on. So I'll see you guys on Monday, get all that stuff done. Okay, bye-bye.